Cambridge IGCSE Chemistry, Paper 4, Theory Extended, Variant 2, February-March 2020. Question number 1. Petroleum is a useful natural resource. The diagram shows how petroleum can be separated into useful substances. A. What is the name of the separation process shown in the diagram? This is fractional distillation. Right? Fractional distillation. B. Name the fraction leaving at A and B. The most bottom layer will have bitumen, and the one between gasoline and kerosene is naphtha. Right, so let me just copy and paste this to, cut and paste. All right, moving on to C. Refinery gas is a mixture of hydrocarbons. One refinery gas is butane, C4H10. 1. Suggest the names of 2 other refinery gases. So you can give me members of the same homologous series as alkanes, which are, for example, methane, or ethane, or even propane, for example. All right. 2. Write the chemical equation for the complete combustion of butane. So whenever you see the word complete combustion, you should think of it as a reaction of fuel, that is the butane, mixing with oxygen gas, which is O2, forming 2 products. In complete combustion, it forms carbon dioxide and water. All right, next is balancing, which is the difficult part, the second mark component. I will say that the tip for this balancing is balance the carbon first, which you can put a 4 on the right hand side of carbon dioxide due to the fact that there are 4 carbon atoms on the left hand side. And then look at hydrogen. There's 10 atoms of hydrogen on the left, which means that here you have to put a 5 in order to make 5 sets of 2, making it 10 altogether. Then count altogether how many oxygen atoms are there on the right, which is 8 plus 5. So there are 13 atoms in total for oxygen. So there are 2 variations of this equation, which is you can put 13 over 2. All right, so that makes the number of oxygen atoms 13, or you can choose to convert these ratios into whole number ratios. So I'm going to multiply every number here by 2, which gives me 2 to 13 to 8 to 10. All right, so let me rewrite this into a whole number ratio, 2 to 13 to 8 to 10. All right, moving on to 3. Name the toxic gas produced by the incomplete combustion of butane. So when you see the word incomplete combustion, you should think of substances like soot and also carbon monoxide. Right, moving on to the next question. D. Gasoline and kerosene are both fuels. They have different properties. 1. Describe the differences in the properties given. Viscosity of the fuel and flammability of the fuel. Now, as you can see from the fractions, gasoline is on a higher position than the kerosene, which means that it is having a less viscous consistency, right? Gasoline is less viscous than kerosene. In terms of flammability, right? Kerosene is actually less flammable, then gasoline is more flammable. Then kerosene. All right. So that's why we don't exactly use the bottom fraction as burning oils, right? As they are very viscous and it's not exactly as flammable as the lighter fractions. All right. Moving on to the next question. 2. What difference in the molecules of gasoline and kerosene causes these differences in properties? So ultimately, why does gasoline have a less viscosity than kerosene? Because it simply has smaller molecules, right? Shorter carbon chain molecules. So gasoline has shorter chain molecules compared to kerosene. Right? Moving on to E, hydrogen fuel cells can be used to power vehicles. Write the word equation for the overall reaction that takes place in the hydrogen fuel cell. So it's as simple as ABC, hydrogen reacts with oxygen, producing water in the process. All right, that's hydrogen fuel cell in a nutshell. Moving on to the next question. 2. Aluminium is extracted from its ore. The ore is converted into pure aluminium oxide, which then undergoes electrolysis as shown. A1, name an ore of aluminium. So there will be bauxite. 2. What is meant by the term electrolysis? You have to define it based on the word electro and lysis. Okay, lysis means breakdown. Electro means by the passage of electricity. All right. So you have to also mention, okay, this is only the first part, but then the second part is what is actually broken down in this process. It is an ionic compound in molten state or in aqueous solution form. All right, so the first mark will be awarded to the breakdown and also by the passage of electricity. The second mark will be awarded to the ionic compound in molten state or aqueous state. Moving on to the next question. Aluminium oxide has a melting point of about 2000 degrees Celsius, but the electrolysis process operates at about 900 degrees Celsius. Name the compound added to aluminium oxide to reduce the operating temperature. That will be cryolite. Okay, the magic substance that allows this experiment, this procedure to be carried out at a lower operating temperature. 2. Suggest one benefit to the environment of reducing the operating temperature. Well, this is a huge production, right? With boiling of, with heating that requires a lot of energy. When a particular operation requires a lot of energy, it means that you need to burn more fossil fuels. So with that, by reducing the operating temperature, that saves the amount of energy, although that is not a good answer. All right. So the more actual benefit from that is that you don't have to burn too much fossil fuels, and hence reducing carbon dioxide emissions. Okay, the focus of the question is on the benefit to the environment itself. So it has to be related to emissions. All right, moving on to 3, write the ionic half equation for the reaction taking place at the negative electrode, which is the cathode, and also the positive electrode, which is the anode. Now, at the negative electrode or the cathode, it's the location where cations get discharged. Right? So what are the cations present in this particular setup? It will be aluminum ions. So aluminum ions get discharged into aluminum. All right? Pure, what do you call it? Solid aluminum. All right? How is that possible? By receiving electrons from the negative electrode. Right? So there will be a first mark. Second part will be balancing. So in order to neutralize this +3 charge, it has to gain 3 electrons. Moving on to the positive electrode, so it's the location where anions get discharged instead. So from the setup, what are the ions? What are the anions that are present? It's the oxide ions. So oxide ions get discharged, their charges disappear, and turns them into oxygen gas, which is O2, all right? So how is that possible? A negative species converts into a neutral species by giving away electrons. The next part is balancing, which is there are 2 oxygen atoms on the right, which means that you need to put a 2 in front of the oxide on the left. And then here, the sum of negative charges needed to be neutralized is -4. So which means that the substance needs to release 4 electrons, okay, to form a complete oxygen molecule. 4, explain why the anodes need frequent replacement. As you can see, anode forms a lot of oxygen gas. And in this setup, these electrodes are actually graphites. All right, so the graphite electrodes may get oxidized to form carbon dioxide. Right, the first mark is the part where you see graphite electrodes gets oxidized, or you can say reacts with oxygen. And then the second part is the product, which is to form carbon dioxide. That gives you 2 marks. Moving on to C, aluminum oxide reacts with acids and with alkalis. 1, what term is used to describe an oxide that reacts with acids and with alkalis? So it is like the chemistry version of amphibians. Right, amphibians are living organisms that live in watery areas and also on land. So this is having both properties. You call this amphoteric. All right. So the prefix amph means both. 2, aluminum oxide reacts with dilute sulfuric acid to form a salt. State the name and write the formula of the salt form. So dilute sulfuric acid contains sulfate ions. All right, because dilute sulfuric acid chemical name is hydrogen sulfate. So the sulfate may react, or should I say will react, with the aluminum to form aluminum sulfate. And the formula for aluminum sulfate is aluminum is a group 3 ion, so it will carry a 3 plus charge. Sulfate is carry a 2 minus charge. So you cross these numbers and then you get Al2, and then SO4 as a whole, there will be 3 of them. So that's the formula of aluminum sulfate. Moving on to the next question. Aluminum oxide reacts with dilute sodium hydroxide to form a salt and one other product. Name the other product. So what is this reaction actually? Aluminum oxide and sodium hydroxide. So it should form water. Right, because there's oxygen and hydrogen present, so it will form water. Now next, 4. Aluminum hydroxide, AlOH3, decomposes when heated to form aluminum oxide and water. Write the chemical equation for this reaction. So aluminum oxide is given, decomposes into aluminum oxide. So the formula for aluminum oxide is Al2O3. And water, H2O. Next is the balancing, which is by observation, there are 2 atoms of aluminum, actually ions of aluminum on the right. So you need 2 aluminum hydroxides. And then observe more. There's 6 sets of OH on the left altogether. And on the right, there's 3 oxygen atoms, actually ions on the aluminum oxide, and 1 oxygen on the water. So in order to make this possible, you have to put a 3 in front of water. Right, so that makes all together oxygen and hydrogen, 6 of them. So that's the answer for 4. All right, 5. Suggest the names of 2 other aluminum compounds that decompose when heated to form aluminum oxide. So it's a heat decomposition reaction. What kinds of chemical substances can decompose under heat? Examples of that include carbonates and nitrates. Right, when they decompose by heating, they form metal oxides, generally. All right, there are exceptions to this rule, but it is good enough for this question. So that will be aluminum carbonate and aluminum nitrate. Right, moving on to the next question, which is question number 3. The periodic table is a method of classifying elements. Identify the element which is in group 4 and period 4. So, group is the vertical columns. So that will be the carbon, group 6, it's not group 4. Group 6 is the oxygen, sulfur, and selenium. And then period 4 will be the 4th row, which is selenium. Right, don't get tricked by the absence of an element on period 1, group 6. All right. Selenium belongs to actually row number 4. So there will be selenium. B, calcium is in group 2 and chlorine is in group 7 of the periodic table. explain in terms of number of outer shell electrons and electron transfer how calcium atoms and chlorine atoms form ions. Give the formula of the ions form. So this is a 5 marks question. Oh wow, okay. So the question is asking for how the atoms form ions in terms of outer shell electrons and electron transfer. So let's stick to the question. Oh, the app is not working. Wait. Started to be fine now. Right. So allow me to outline this, but in exam, please write them in full sentences. So you have calcium. Calcium, the outer shell electrons is 2 due to its position in group 2. Right? So outer shell electrons, you refer to the group. And how many electrons does it need to give or take? It will be giving 2. Right? So whereas for chlorine, it belongs to group 7, which means that it has 7 outer electrons. So will it be taking or giving? It will be more towards taking from others. All right. So that leads to, well, having to add 1 more electron. So you just mentioned calcium has 2 outer shell electrons. It will transfer 2 electrons to form Ta2 plus ions. Then chlorine has 7 outer shell electrons. It has to receive 1 electron to form chloride ions. Right, so the first mark is awarded by having the correct number of outer shell electrons. The second mark is calcium has to lose electrons, and then chlorine has to gain electrons. Right, and then the final outcome, which is the name of the ions. So in total, there will be 5 marks. Moving on to the next question. C. Group 5 chlorides are covalent molecules. The boiling points of some group 5 chlorides are shown. 1. Suggest the approximate boiling point of PCl3. Now, if you notice closely, from the periodic table, N, P, A, S, and also SB are actually group 5 elements. And as we know, going down the group, the sizes become larger. So a larger size down the group leads to, essentially, you can see also another observation is increase in boiling point. Right, so the approximate boiling point for PCl3, you can give me either between 72 until 129. So let's just pick 111, just because I like it. Okay, 2. Explain the trend in boiling points in terms of attractive forces between particles. Well, as we can see, the boiling points increases due to stronger attractive forces between the molecules. Right? So remember that stronger force of attraction means that it's more difficult to separate the particles apart from each other. All right? So moving on to the next question. There's a problem with my iPad. Wait, give me a second. I'm gonna close this app real quick and hopefully it solves the problem. Okay. Moving on to the next question, 3. Complete the dot and cross diagram to show the electron arrangement in the molecule of PCl3. Show outer electrons only. So, based on the periodic table, phosphorus belongs to group 5 and chlorine belongs to group 7. So, how many electrons are needed in order for phosphorus and chlorine to form that molecule? So, each chlorine atom will need 1 more electron, which each phosphorus atom will need 3 more electrons. Okay, it needs 3 more electrons. So, how can you construct this diagram? So, chlorine each contributes 1 electron for sharing, right? And then phosphorus will contribute 1 electron to each chlorine atom, which makes it 3 electrons are contributed by phosphorus to form the bond pairs. Okay, that will be your first mark, I believe. And then your second mark is the correct number of non-bonding electrons. So chlorine is a group 7 element, which means that it would have 6 more electrons that are not affected by the bonding for each of the chlorine atoms. So there will be 7 electrons in total from the chlorine. And then for phosphorus, because it's a group 5 element, it essentially shared 3 electrons for sharing, which means that it is left only 2 more. All right, 2 more electrons that are non-bonding. Right, so move on to D. PCl3 reacts with chlorine Cl2 to form PCl5. This reaction is exothermic and reaches an equilibrium. I. Describe 2 features of an equilibrium. When a reaction is equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. And as a result of that, the concentration of the reactants and products remains unchanged. All right, moving on to 2. State the effect, if any, on the position of this equilibrium when the following changes are made. Explain your answers. In an equilibrium reaction, when the temperature is increased, it should shift the position to the side that is endothermic, right? So it will be shifting towards the left-hand side, which means that there will be the rate of the, sorry, it's just essentially there will be less yield, right? So actually, I just realized that this question only asks for the position. So let's just write that down. So it shifts to the, so the observation, which is shift towards the left hand side of the reaction. Why? Because increasing temperature shifts the equilibrium position to the endothermic side. Or you can just give me as because the forward reaction is exothermic. Now, the second part, which is pressure is increased. Now, when pressure is increased, it will shift the position to the side with less moles of gases. So from the equation, on the left, in total, there are 2 moles. On the right, there's only 1 mole. So which side has less mole of gases? It will be towards the right-hand side. So it will be shifting towards the right-hand side of the equation because increasing pressure leads to the shifting of the equilibrium position to the side with less number of moles of gases. Right? So moving on to 3, explain in terms of particles what happens to the rate of the forward reaction when the reaction mixture is heated. So this question no longer asks for equilibrium, it's all about rate. So what happens when the reactant mixture is heated? So that will lead to an increased rate of reaction, which is the final outcome. Why? So let's do a cause to effect explanation. So start with, because the particles gain kinetic energy. I can just say gain more energy. And then they start to collide faster, or should I say collide more per time. I can just say collision rate increases. Then you can see that more successive collision rate, or I can see fraction, or I can see percentage. Sorry, let's just stick to the word rate. Okay, or I can just explore the activation energy concept, which is just say that there will be more particles that do collisions with energy greater than the activation energy. That can also be an answer. All right. So moving on to E, PCl5 reacts with lithium fluoride, LiF, to form LiPF6. Calculate the mass of LiF needed to form 3.04 gram of LiPF6 using the following steps. The first part, calculate the number of moles of LiPF6 formed. So we are given the mass and we are given the molar mass, actually given the relative mass, hence essentially they are giving you the molar mass as well. So what's the formula for this question? By taking mass over molar mass. So it is a fraction of the molar mass. So 3.04 out of 152. So how many moles is that actually? You should use your calculator and punch the numbers out. Sorry, punch numbers in your calculator and you should be able to get the answer, which is 0.02. So from the equation itself, it tells me that the theoretical ratio is a 1 to 6 to 1 to 5 ratio. 1 to 6 to 1 to 5 ratio. All right. So the second part asks you for deduce the number of moles of LiF needed. So in order to form 1 LiF, you need 6. Sorry, in order to form 1 LiPF6, you need 6 LiFs. Right. So in the equation, that's the theoretical molar ratio. In the reality, in the actual experiment, you are using 0.02 moles of the product. So how many moles of LIF are you using actually? So all you need to do is multiply by the conversion factor, multiply by 0.02, and then you should be able to get the answer. It will be 0.12. So take 6 multiply by 0.02. That gives you 0.12. All right, so find the mass of LIF needed. So C's equation tells you that you need 0.12 moles of LIF. So convert this to mass by taking the number of moles multiplied by the molar mass of this substance. So it will be 0.12 multiplied by the molar mass of LIF, which is actually not given. So you need to find it out by using the periodic table. Lithium has a mass of 7, and then fluorine actually has a mass of, if I'm not mistaken, 19. It turns out that my periodic table doesn't have the mass number. Like, give me 10 seconds to find the periodic table on the net. Yeah. Okay, so LIF will be 7 plus 19. That will make 26. So 0.12 multiplied by 26 gives you 3.12 grams. All right. F. Lithium fluoride has ionic bonding. What is an ionic bond? So, ionic bond, okay, not sure about why my app is not working today. Hopefully it doesn't happen again. All right, so an ionic bond is formed between ions. So how do you describe a bond? Attraction. Right? Attraction between the ions. So we need to translate the word ion. They are essentially oppositely charged. Particles. Right? It's the electrostatic attraction between oppositely charged particles, or you can just give me as ions. All right. 2. Give 2 physical properties of ionic compounds. That's pretty straightforward. Ionic compounds, like for example, your salt, okay, and then like your eggshells, which contains calcium carbonate. Okay, what are the physical properties of these ionic compounds? It will be, for example, they have very high boiling point and melting point. That's why you find them mostly as solid at room temperature and pressure. And apart from that, they are also mostly soluble in water. Right, salt is soluble in water. I'm sorry for giving the calcium carbonate as an example. Okay, because calcium carbonate has a few like special exceptions from the general characteristics. All right, so as you know, salt generally is soluble in water. Right, apart from that, you can also talk about electrolysis. Right, we do ionic compounds. We do electrolysis on ionic compounds. So you can see that they conduct electricity when in aqueous state or in molten state. Okay, so that's the answer for 2. Now, let's move on to number 4. Iron is a typical transition element. Iron acts as a catalyst, forms colored compounds, and has more than one oxidation state. A. Name one major industrial process that uses iron as a catalyst and name the product made in this process. That will be Haber process, to form ammonia. Right, and then the ammonia can be used to make fertilizers. Now, B, when aqueous sodium hydroxide is added to aqueous iron 2 sulfate, a precipitate forms. What is the color of this precipitate? Whenever you see the word iron 2, you should think of it as a green ion. Most of the cases, okay, in most of the cases, iron 2 is green in color. So the precipitate that it forms is green. Write the ionic equation for this reaction and include the state symbols. So this is a precipitation reaction. A precipitation reaction is characterized by an aqueous reactant combining with another aqueous reactant to form a solid precipitate. All right, precipitate means that it's insoluble, it's solid in nature. So the ionic equation will be iron 2 reacting with what is actually the contributor here is the hydroxide ions. All right, and that forms the precipitate, which is actually iron 2 hydroxide. And make sure to balance the equation. There will be your second mark, which is putting a 2 in front of OH as you have 2 OH on the right. That's it. Right. So 3 marks. The first mark is your chemicals. The second mark is the numbers, the balancing part. And the third mark is for the state symbols. Now, C. Iron 2 sulfate can be converted to iron 3 sulfate by using potassium manganate 7 at room temperature. 1. What is the role of potassium manganate 7 in this reaction? It's an oxidizing reagent. Right? Remember that. As you can see, it went from iron 2 to iron 3. There's actually an oxidation process. So this chemical acts as an agent for that. 2. What condition must be used for this reaction to occur? It must be acidified. Right? Or you can see presence of an acid. Without acid, it doesn't work as an oxidizing agent. 3. In terms of electron transfer, what happens to iron 2 ions in this reaction? So iron 2 ions, in order to convert to iron 3 ions, right, it has to give away an electron. All right, so this equation is not needed. You just need to mention in terms of electron transfer. So you can just say electron, 1 electron is lost. Now 4, state the color change seen during this reaction. So acidified potassium manganate 7 is purple in color, but once it carries out its reaction, it gets reduced in the process, hence it turns into colorless. Okay, chemically it actually went from manganate ions to manganese 2 ion, which is colorless in nature. All right, D, deduce the charge of the iron ion in each of these compounds. So let's figure that out. Fluoride is -1. So essentially you have to do your maths. Fe oxidation number with 3 -1 fluorides carries the overall charge as 0. So the oxidation number of Fe will be +3. Similarly, that goes with nitrates, which also carries a -1 charge. So a similar calculation applies. So the charge of the iron ion is also the same for iron 3, nitrate. Moving on to 5, there are two types of polymers. Addition polymers are made from many identical small units. 1. What is the term used to describe these small units? So polymers are made from monomers. Polymers are made from monomers. Moving on to 2, a section of an addition polymer is shown. Draw the structure of the small unit used to make this addition polymer and show all of the atoms and all of the bonds. Ooh, okay. So this is an addition polymerization. In order for addition polymerization to occur, the monomers must have usually unsaturated hydrocarbon. Like they have to be, let me rephrase that. They have to have unsaturated double bonds or triple bonds actually. Right. So with that said, how can we convert this back to a double bond? All right, so let's figure out the repeating part first. The repeating part is this one. Let's draw that out anyway. C, CH3, H, CH3, and H. Okay, that's the repeating part. That's not the monomer. All right. The repeating structure is this one. Now, so all you need to do is converting these two single bonds, okay, into the double bond at the center. Like this. All right, so that will be the monomer structure. Let me check the answers just for a short moment. So yes, the first mark is the double bond. The second mark is the structure. This structure, that's technical name for it, it's methyl-propyl. Okay, so for B, polyamides are condensation polymers. What does the term condensation mean when used to describe this type of polymer? Usually condensation means removal of water when the product is formed. All right, question C. A polyamide can be made from two different molecules. A simplified structure of octane dioic acid is shown. A simplified structure of 1,6-diaminohexane is shown. 1. Complete the diagram to show a section of polyamide manufactured from octane dioic acid and 1,6-diaminohexane. Include all of the atoms and all of the bonds in the linkages. Now, this is a polyamide. It's a condensation polymer, which means that water molecule will get removed. So, how can we form the linkage? By removing water, H2O. So, all you need to do is take away an OH and also take away a H. All right, so let me just draw the basic structure first. So, for the gray box, you see that it has a carbon and a double bond to oxygen for each side. And then for the white box, it has a nitrogen atom on each side, covalently bonded to a hydrogen. Right, that's what you see. So the linkage will behave like every time there's a white to a gray box, the linkage will look like this. And then for every gray box that links to the next white box, the linkage will look like this. Right? So what we need to do is just copy and paste this thing down. So there's a white to gray box. Then the linkage will look like this, and that. Right? So this linkage will be the same for this side. And finally, for the gray box and the white box, the linkage will be a CO followed by an NH. Like this. All right, then the ending of the gray box will look like this. All right, so make sure that you know what is removed from the two boxes and also how the linkage look like. Let's double check our answers. We have a NH on the left and an NHCO. Then the gray box is followed by a CO and then NH, and then white box, NHCO, gray box, CO. And then this structure repeats throughout the polyamide structure. Now, 2, state the name of a synthetic polyamide. The most popular example is nylon. Right? So that's the end of the discussion of this paper. Thank you for watching.